So in this lecture, we're going to see the diode. So as you see over here, this is a diode, as you see. So we have here a diode, as you see, and we have here a sign here. As you see, this bar means the cathode, and here we have the anode, okay, as you see. So this is cathode and this is anode, okay. So this is the symbol for the diode, as you see over here. So this is the symbol for the diode, okay. Here we have cathode and here we have anode, exactly like this one. As you see, we have cathode and we have anode, okay. Or here, this is a negative terminal and this is a positive terminal, okay. So the working principle of the diode is this: the diode let the current pass in this direction. So this is the direction of the signals. So the diode let the energy pass just in this direction, but it block the energy in this direction. As you see, this is like it block the energy in this direction, okay. So that's why we use the diode in some circuit as a protection component. For example, if we have, for example, here, as you see, 12 volts, so for example, we have here a 12 volt power that will go, for example, through this IC, for example. Here we have some capacitors, for example, okay. Here we can use a diode exactly in this side, and the anode should be to the ground. So for example, if the power increase more than 12 volt, this diode will burn out and then it will protect the circuit. So we use the diode sometimes into protection, okay. So to check a diode using the multimeter, to check it if it is good or not, you should always use the multimeter, and you should always put the multimeter to the buzzer option or the continuity, as you see here. And let's switch on the multimeter, okay, and let's check this probe. Now it's good. So you should check the diode by putting the black probe here in the cathode and the red probe here in the anode. Using this method, you should get a reading in the multimeter, and by put the red probe here in the cathode or negative terminal and the black probe here, you will not get anything here. So let's check a diode, as you see over here. So we have here diode, as you see, okay. So let's put it here. So we have here diode, okay. So as you see, so here we have cathode. So here we have cathode and here we have anode. So let's put our probes here, as you see. Excuse me. As you see, we have a reading, okay. But if we inverse this, now we will put the red probe in the cathode and the black probe in the anode, as you see. So you don't get any reading, as you see, okay. So this diode is good. When the diode is bad, you will hear a buzzer in the multimeter, okay. When the diode is bad, the diode will be like a wire. You will hear a buzzer in the multimeter, okay. So there is another type of diode, this with the same working principle, okay. This is the Zener diode, okay. This is the Zener diode, as you see here. So here, this black part is the cathode and here we have the anode, okay. The same principle as a normal diode. So here we have a normal diode, as you see, and this is a Zener diode. Okay, this is the symbol for the Zener diode. Okay, this is the Zener diode, but with the same working principle as the normal diode. But often we use the Zener diode to stabilize the current in the current stabilization. Okay,